Greetings, greetings. Yes, okay. I was waiting for the recording to start, so that we can comment with our lesson, with our lesson. First thing first, I would like to welcome everyone that has joined our meeting today. And hopefully you guys had an amazing weekend. I hope you guys had an amazing weekend, and you also were able to go through those questions that I gave you guys on Friday. On Friday, because I think I should emphasize this again. With as much as I'm here, teaching you, helping you guys with these things, but uh, what will be the game changer for you? It's actually you sitting down um and actually trying to do these things by yourself. That is what will be the game changer for you guys. So we're gonna do a little bit of a revision. We are still on trigonometry, and then I think we have quite a few examples or few questions that we're gonna go through, just to sort of solidify the concepts that we are talking about, and then depending on how much time we have, we may go into the trigonometric functions, or we just do trigonometric functions on Wednesday. And then I think if we do them on Wednesday, we're also gonna have like enough time to do their examples. But yeah, guys, without wasting any more time, let's get into it. So, uh, on Friday we introduced the topic of trigonometry, and we said that trigonometry was essentially a study uh, of relationships between sides and angles. That is what we deal with. Please mute yourself, guys. Please mute yourself. Please mute yourself so that we don't disturb the lesson.
Can you teach us trigonometry function, please?
Spogo, please mute yourself. Okay, yeah, I think you have muted yourself. Then,
I love this session. I love this session.
okay, we understand that. Please mute yourself so that we can proceed with our lesson, and then I will give you a chance to ask questions later on.
Oh, thank you very much.
Okay. Okay, guys, let's carry on. Let's carry on. So, as I was still saying, that trigonometry is basically the study of relationships between sides and angles, and it's mainly focused, or it's mostly focused on triangles. On triangles, we are trying to find those relationships and ways to relate the relationships between the angles and the sides of triangles. This is the side as you know them by now. You know them, and the angles is what we find here inside. We have already talked about that, and you guys are already familiar with that. Those are your angles. That is what we relate in trigonometry. And then we also introduce this diagram that we have here, the Cartesian plane. That sometimes we look at the angles from the Cartesian plane and not from the triangles as we are used to, especially when we are dealing with angles that maybe are more than 180 degrees, or angles, yes, when we are dealing with big angles. So we just simply use the Cartesian plane because it can cover even the bigger angles, even but the logic is still the same. So we generally start here from zero, and then we go counterclockwise or anti-clockwise. We go in that direction. We go counterclockwise when we are looking at the angles. That's the positive direction for the angle. When we go in clockwise, it's the negative direction. Okay, then we introduce right angled triangles, right angle triangles. So with right angle triangles, what we emphasize is that one of the angles within that triangle will be actually equal to 90 degrees, as it is highlighted here, will be equal to 90 degrees. And some of the properties of the right angle triangles that are specific for the right angle triangle is the sides here, they have names, the sides. Starting with the side that faces the 90 degrees angle here, of which is this longest side of the triangle is called what? The hypotenuse side. This is the side that I'm talking about. It's called the hypotenuse side. It's always opposite to the 90 degrees. It's always opposite to the 90 degrees angle, and it's always the longest side in the right angle triangle. And we also have the adjacent side on the right angle triangle. And remember, as I told you, that we are saying it's adjacent because it is next to the angle that we are dealing with, or the angle that we are considering at that time, of which in this case we made an example using this theta here. That's okay. The side that is next to the theta here will be our adjacent side. If let's say maybe we were dealing with an angle beta here, of course this was gonna be the adjacent side. But for now, let's focus on this angle theta here, just not to confuse it, just not to confuse you guys. And then we also have the opposite side here that is represented by O. So this side is opposite to the angle theta that we are dealing with. Remember, the hypotenuse side, we said it's opposite, or it's facing the 90 degrees angle. It's facing the 90 degrees angle. But with the opposite side, it is facing the angle theta that we are dealing with, or that we are considering at the time of our study. And then here I made another example. So when we were considering angle beta instead of angle theta, I think I wrote this one later. But we're considering, if we're considering angle beta, then the side that will be next to angle beta is gonna be this side, of which this is gonna be what is gonna be our adjacent side. And then the side that faces 90 degrees angle is still what? Still the hypotenuse side, still the longest side in the right angle triangle. And then we're gonna have the side that faces the angle beta that we are dealing with, or that we are considering at that time, or for that case, and that's always the opposite side. And then another thing, as I mentioned, is that the sum of angles. So when we add up all of the angles, that's when I introduce this angle theta here. And then I say when we add up all of the angles in the triangle, they will always add up to what? They will always add up to 180. They will always add up to 180. So sometimes maybe we'll be given two angles in a question, and then maybe you'll be asked to find the dead angles. When you have two angles already, you can simply add them and then find the dead angle. I even gave you guys an example here that, let's say, angle theta here was 30 degrees, and we are asked to find angle beta here. So you simply add all of those angles in the triangle and equate them to what? And equate them to 180, of which is the size of the angles in a triangle. And then you solve for beta, of which in this case it was what? It was 60 degrees. So those are the properties of right angle triangle. Let's move forward, guys. And then since we have introduced the names of the sides and the angles in the right angle triangle, we also introduced the trigonometric ratios. So you may be already familiar with the trigonometric ratios, but we simply have these three basic trigonometric ratios, of which is the sine, cos, and tan. Those are the three basic trigonometric ratios. And then for sine, we said sine deals with what? Deals with the opposite side and the hypotenuse side. So it's the side that faces our angle. If we're dealing with it with theta, just like this case, it's the side that faces theta over the hypotenuse side. That is the trigonometric ratio of sine. Is opposite over hypotenuse. So sine theta will always be equal to the opposite side over the hypotenuse side. The hypotenuse side is the side that faces 90 degrees. The 90 degrees angle. Always keep that in mind. Okay. And then let's move forward. We also have the trigonometric ratio of cos theta, of which is the adjacent side over the hypotenuse side. And then also said that note the commonality between the two. That is always a side over a hypotenuse side. But with the last one, it's different, of which is tan. Tan deals with the opposite and the hypotenuse and the adjacent side. The hypotenuse side is no longer included. And then I gave you guys this abbreviation here, or this mnemonic here to help you memorize or remember these trigonometric ratios easily, of which is soccer, toa. And then you just know, okay, with the S stands for what? Stands for sine. The O stands for what? For the opposite side, and the H for the hypotenuse. With car, it's the C stands for cos, and the A stands for adjacent, and the H stands for hypotenuse. And then with toa, the T stands for tan, and the O stands for opposite, and the A stands for adjacent. So this is very important. This is the building block of everything in trigonometry. In trigonometry. So it's very important that you know these ratios and you memorize them, because you're gonna basically use these ratios throughout. It's these ratios and the Pythagoras theorem that you're gonna use to answer or to solve your problems in trigonometry. And then we also introduce the reciprocals of these ratios, so whereby instead of having an opposite side over the hypotenuse side, we now have a what's hypotenuse side over the opposite side. Then we have a reciprocal that is called a cosec. That's a reciprocal of what? A reciprocal of sine. And we have, so basically a reciprocal is when we say 1 over sine theta, as it is shown here, That's a reciprocal, you know. That's a reciprocal. And then the reciprocal, of course, it's what? It's sec, of which is hypotenuse over the adjacent side. And then let's move ahead. And then we also introduce the reciprocal of tan, of which is called theta. And guys, if I'm talking too fast, please let me know. I'm just uh trying to get through these things as quickly as possible, because we've already done it on Friday. We have already done it, so it's just a revision so that we can have time for the questions. Because it's very important to have questions. To deal with questions. Uh, okay. Let's see.
Can I ask any questions?
Yeah. You can ask a question. Okay, let me come back here.
Your session today was amazing. This was my first time.
Oh, today or on Friday? Today.
Yeah.
Okay. Thank you, sir. What is the
Yeah,
question?
I am from South Africa, and at school, eh,
At school? Yes, carry on.
at school we are learning geometry functions,
Oh,
assembly work.
geometry functions.
Yeah,
Okay, we're gonna get to them, because I asked on the group that what should I do, and people wanted to do the trigonometry. So maybe after we are done with trigonometric functions, we'll go to geometry.
yeah. So,
Yeah.
where are you from?
Oh, I'm also from South Africa.
Oh, yeah. Do you know Adams College?
Adams College. Yeah, I know Adams College, but I know it from social media.
Yeah, that is my school.
Oh, that's your school.
Yeah,
Okay, that's nice. That's nice. Maybe we'll come there one day at your school, ne? And please also tell
yeah.
other learners to join
It will
ICampSA.
be wonderful.
Yeah. You show us around, eh?
Yeah, I will show you guys.
Okay, that's amazing. Okay, let's carry on
So,
with the today's lesson. Oh, you still have a question?
yeah, it's so your basics, and we did this on term 2.
Oh, what we are doing here?
Yeah,
Oh, okay. So it's basically a revision, because I didn't know what you guys are actually doing at this time. But since you have told me, then we'll try to move into term three work and then maybe term four work before you guys even get to that work. So that's when you do it at school, it's more of a revision, so you guys can be ahead.
You you are doing good work, and this time we'll do more. We'll pass maths.
Of course, that's what we want, guys. We want you guys to excel there by maths.
Yeah.
Yes, yes. Okay, let's carry on with the session.
It's okay. You can continue.
Okay, please mute yourself. No? Okay, so that was it about the reciprocal and the trigonometric ratios. Okay, and then we introduce special triangles, and I didn't know that you guys already have done this, but okay, it's good for a revision. Anyway, with the special triangles, so it's basically these angles that we see here, which has some sort of a standard ratios or ratios that you need to memorize, because you need to basically know this. As much as you are allowed to bring your calculator into the exam venue or into the test venue, it is very important to memorize these ratios for his special triangles. So the first one, it's whereby we have two 45 degrees, two 45 degrees angles, and the 90 degrees. And remember that the sum of angles in a triangle, they add up to 180. So 45 plus 45 is going to be 90, and then plus this 90 here, it's 180 degrees, and then with the side, we're gonna have one, and the root two, and then you already know when we are dealing with the sign that the ratio for sine is what? It's opposite over hypotenuse. So let's say we're looking at this angle 45 here. It's gonna be what? It's gonna be opposite, opposite of which is 1 over hypotenuse. And I also introduced these things here and I ask you guys to go and punch it on a calculator or try to prove it to yourself that 1 over root 2 is actually equal to root 2 over 2. So these are basically the same thing. I know that here is written root 2 over 2, but here I also did some calculations for you guys so that you can see where we get this. Okay, and then so these are the ratios. Sine of 0 degrees will result in 0. I made an example for you guys. I don't know, maybe here I can't remember. That's when the angle becomes smaller and smaller, we end up not having the opposite side. The opposite side will end up being 0. And then if we say 0 over the hypotenuse side, anything 0 divided by anything will always result in what? Will always result in 0. So I made a demonstration for you guys in order to understand how did we came about with this 0 here, And then I think with the other ones, you can basically see here, let's say we're taking this one, sine 30. Sine 30 is opposite over hypotenuse, so it's 1 over 2, 1 over 2. So with the other ones, you can basically see from these triangles here, So the second special triangle, it has the angle of 30 degrees and 60 degrees, and then the sides is 1, it's 1, 2, and root 3. Those are the sides, and these ratios you just need to memorize them. But even if you forget them, you can simply punch them in your calculator. They're gonna come out like this. And then we have the ratio for the three trigonometric trigonometric uh trigonometric terms or something. This sine, cos, and tan. So we have all these ratios here. For all the angles from 0 to 90 degrees, and then once again, soccer tower, just keep it in mind. It will always come in handy. And then we also did the Pythagoras theorem, of which we said it's what? C squared will always be equal to b squared plus a squared. This is not negative here. This was like a star or something. It's not negative. So a squared plus b squared is equal to c squared, or is equal to the hypotenuse side. So when you take the opposite side and the adjacent side, the square of those sides, when you sum them together, they will always be equal to the square of the hypotenuse side. They will always be equal to the square of the hypotenuse side. Okay. And then, once again, here, what I was introducing is what I mentioned a few minutes earlier, that solving trigonometric equation, the things that we're gonna need is what is the Pythagoras theorem and the trigonometric ratios. So mostly the Pythagoras theorem will help you calculate the sides. Remember what I said when I started this meeting is that trigonometry is basically the study of relationship between sides and angles. So it has all to do with sides and angles. So with the Pythagoras theorem, it will always come in handy when you are actually calculating the sides, when you're calculating the side. And then with the trigonometric ratios, it will always maybe come in handy when you are looking for the angles in the triangle, for the angles. But you can also use the trigonometric ratios to calculate the size, So you can calculate an unknown side or angle when you know an angle and a side. So let's say you are given a triangle that has a side and an angle here and an angle here. So you can basically, if you have this two, you can be able to calculate the hypotenuse side and you can be able to calculate the opposite side by doing what? Let's say if you are given this angle here as 30 degrees, or maybe 35 degrees, and you have this adjacent side, then from there you know that you can use the cost ratio in order to calculate the hypotenuse side. You just simply take that 30, plug it in here, and plug the adjacent side, the value of the adjacent side, in this ratio here, and then solve for the hypotenuse side, and then here, what we presented is the trigonometric ratios in the four quadrants. Basically, I was teaching you guys the cast method. As you can see, CASC, the cast method. So the cast method will help you know uh which ratio is going to be positive in which quadrant. So all ratios are positive in what, in the first quadrant. This is our first quadrant one, as you can see here. Maybe let me use a different color to highlight that. This is quadrant one. This quadrant here is quadrant one. This is quadrant two. This is what I'm talking about. This portion here. Yes, this portion here. This is your quadrant two. That's your quadrant two. And then this portion here is quadrant three, and this is quadrant four. And then I taught you guys the CAS method. Maybe some of you are already familiar with it. So with the CAS method, you start from quadrant four, quadrant one, quadrant two, quadrant three. So in quadrant four, since we have a C there, the C stands for what? For cos. So cos, the ratios for cos will be positive in the fourth quadrant. So what angles do we find in the fourth quadrant? We find angles between 270 and 360 degrees. These are the angles that we find here in the fourth quadrant. Is anything above 270 but below 360 degrees. So you can even punch it in your calculator, maybe say cos 285. You will see that the answer you're gonna get is gonna be positive. But once you start punching, let's say maybe sine 285, of which would be somewhere around here, sine 285, what you will get is is the is a negative outcome, because sine is not positive in the fourth quadrant. And then, but sine is indeed positive in the second quadrant. So all are positive in the first quadrant, sine is positive in the second quadrant, and then lastly tan is positive in the third quadrant. So when you say tan, for any angle that is above 180 degrees but below 270 degrees, because that's the third quadrant. If we say tan, let's say maybe tan 190, the answer that you're gonna get, or you're supposed to get, is a positive outcome, because tan is positive in the third quadrant. Please mute yourself, guys. Okay. So that is basically it with the introduction, and then we did this we did this question number 4. We did question number 4 here. I don't think there is a need for us to go through it again. Maybe I can just quickly read through it, and then for those of you who are not here, just so that you can see what we did and sort of understand the thought process that we followed while answering this question. So in the diagram below, ABC, ACD, and ADE are right angle triangles. So all of these triangles here are right angle triangles. And then PAE is 90 degrees. Here you can already see that's your PAE. This is the angle they're talking about, 90 degrees. And PAC is 30 degrees. So they're talking about this angle here. And then BC is 20 units. And then AD is this here, is 60 units. So what we're asked to find firstly is the length of AC, this length here. What are we given here? We are given an angle of 30 degrees and this side of 20 degrees. You can already see that this side is opposite this angle, so go back to your to your abbreviation of SOHCAHTOA, which trigonometric ratio deals with an opposite side and the hypotenuse, because we are asked to find the hypotenuse here, of which is the h, and we are given the opposite side and this angle here of 30 degrees. So that is your sine. So we say sine 30 is equal to opposite side over hypotenuse side, of which is AC. Then we calculated AC and we find out that it was 40 units. So we basically applied the same thought process again to answer the other questions. Once we had this side here, we can basically calculate this side with Pythagoras theorem. But what we were actually asked for the angle. So we asked for the angle, of which we were given. We already calculated this side AC, and we asked for this angle here. So we had an adjacent side and a hypotenuse side. So we could use cos here. This is what we did. Use cos to calculate the angle here, of which came out to be 48.19 degrees. And then next we're asked to calculate the length of DE. The length of DE. With the length of DE, what we did, we knew that this angle from here to here is 90 degrees, and already we had these two angles, so we can basically calculate this angle here. That's what we did, and we find it to be 11.18 here. We find it to be 11.18, and we already had the side 80, of which is the adjacent side, and then we were looking for the opposite side DE here. So we're dealing with an adjacent and the opposite. So you think you can all tell that's okay, then tan is what was going to be used to calculate that side, and that's what we did there. Calculated that DE of 12.55 units. And then we're solving for x. From there we're asked to solve for x. Of tan x is equal to 2.01. And then so basically here you can see that you are supposed to transpose tan to the other side, whereby it's gonna be tan inverse. You can do this in your calculator, then 2.01. That's what we had there. So here we did that, and then we went ahead to calculate, solve for x for 5 cos x plus 2 is equal to 4. You basically transpose the 2 to the other side, and then you subtract, and then we basically solve for x. I think you guys are already familiar with solving for x, and then we find the value of x there, and then we went on to for the last question we were given a cos x, but we have already dealt with cos x. We've introduced that is actually the reciprocal of sine. So we basically change this into sine x, and then we rearrange this whole thing here, whereby sine was ending up being a subject, and then we could now transpose sine into the other side, whereby we had a sine inverse, and then we could solve for x, and x was 9.6 degrees. X was 9.6 degrees. Okay, so this is the homework that I gave you guys, and I hope you at least attempted to do these questions. You at least attempted to do these questions. So we're just gonna go through them. We're just gonna go through them together right now. So I need to remove these things. And me need to remove them so that we can have space to answer. To answer. So start with this one. Okay. So start with that one. Just trying to create space. Please bear with me. Okay. But we're gonna do all of them. Just wanted to do a quick revision with you guys before we start answering the questions. Just to get you guys back on track. Back on track. Okay. Yeah, we can now begin with the and guys, please, whenever I give you homework, please attempt to do it, because this is how you're gonna learn. Now if I'm gonna give you homework and then you don't do it and then see where you are struggling with it, then it's not gonna be beneficial for any of us. At least attempt to do the homework. If you are struggling somewhere, send on the group. You can help each other on the group. If I'm also available, I will answer the questions. But without wasting any time, let's get into it. So, question 5. In the sketch below, triangle M and P. So, is this triangle they're talking about is drawn having a right angle at N. This is the right angle they are referring to, and MN is equal to 15 units. Okay, A is the midpoint of PN, and AMN, that's the angle, is 21 degrees. So this is the angle they are talking about. This one is 21 degrees. Okay, so what are they saying? Calculate AN. So they are looking for this. They are looking for this initially, AN. And I'm not sure if you've already studied this I think it's similarities or something, but basically these signs here, they mean that the size of AP and AN are actually equal. That's what these two things mean. Those two things I just highlighted there, they mean that these sides are equal. So basically, once we have calculated the length of AN, we essentially also know the length of AP, because of these two things that they gave us there to represent that they are equal. So let's go ahead and calculate the value of AN 5.1.1. AN. So what are we given? We are given this angle here, of which is 21 degrees. Let's just call it theta. Theta is equal to 21 degrees. And then we are given the side, a side that is next to the angle, a side that is next to the, please note that, of which is 15 degrees. Sorry, it's not 15 degrees, 15 units. It's 15 units. So, and we are asked to calculate this side, which is opposite, the side that is opposite of the angle, the side that is opposite of the angle. So, let's go back let's memorize. So, so we have an adjacent, we are looking for an opposite. So you can clearly see that we're gonna be dealing with so, of which is tan. So 10 of 21 degrees is equal to the opposite sides over adjacent is equal to AN over what's the adjacent, 15 units. Therefore, let me write here, therefore AN, you simply multiply by that 15, is equal to 15 tan 21 degrees. And what is the answer as we are getting? 15 tan 21 degrees is equal to 5.7 5.76 units. Hopefully, you guys are also punching your calculators that side just to make sure that we are all guessing the same answers. Just to make sure that we are all guessing the same answers. So that's the first one. The value of an. Okay, then let's move on. So what I will ask to calculate next is PMN. PMN. So we are asked to essentially calculate this big angle here. This big angle here. So we've already calculated this side and we find out to be 5.76. And what do we have? We have this side of 15 degrees. But remember what I told you is that these two things, they represent that these sides are equal. So we essentially also know now that AP is what? It's also 5.76 degrees. So if we add these two, we find the side of what? We find the side of PN. PN. Okay, say, let's just say 5.1.2. 5.1.2. PN, the length of PN is equal to AN times 2, or maybe AN plus PA. Okay, so 5.76 plus 5.76 plus 5.76. PN is equal to plus 11.51. 11, okay, 0.52. Let's just 0.5159. Yeah, let's keep 4 decimals for now because it's not the final answer. Okay, so right now we have the side A,
Oh,
and we have this side here. So we can essentially calculate this angle. Okay, let me rewrite this here. Like this, we're looking for this big angle, not that 21. This big angle, since it's PMN. So what side do we have? We have the adjacent side. The side that is next to the angle. We have the adjacent side, and we have what? We have PN, of which is what? PN is the opposite side. So once again, which ratio we're gonna use? We're gonna use TOA or just tan.
yeah.
So
That indeed. This one is confusing me.
it was confusing, but now you see.
Yeah, we did at class. Yeah, yesterday we did this at class.
For this example,
Yes,
okay, I'm glad now that you can actually see what's happening here. You can actually
yes.
see. Okay, let's move on. So it's gonna be tan of that angle that we are looking for. Let's call it x, angle x. So x is essentially that angle PMN that we are looking for. I'm just putting x there for simplicity. For simplicity. Okay, so we said tan is opposite over adjacent. So what's the opposite side? Is 11.51559. Okay. And then our adjacent side it's 15. Then solving for x is equal to tan inverse. You can simply punch your calculator. If you use a Casio, it's shift tan, you're gonna get tan inverse because we are putting tan on the other side now. If you're using a sharp, I think you press second function, then press tan, and then you put it on the other side. Okay, 11.5159 over 15. Let's find the value of x. Tan 11.5159 over 15, and then we find that x is equal to 37.51 degrees. This
Whoa,
is our answer.
you're amazing.
Thank you. Okay, this is our PMN is
Let me
equal
take
to
my calculator.
yeah, I can take your calculator and verify. I can also make mistake, guys. So it's very important that you also punch your calculator just to verify that I'm not making mistakes. Okay, let's move on. If everyone is clear on these parts, we can move on. Okay, for 5.2, oh no, 5.1.3, almost jump 5.1.3, 5.1.3. So for 5.1.3, what are we asked? We are asked to find the value of MP, that side. And we already have these two sides. We already have this side here, side PN. Maybe let me put in. We already have this side here, and we already have this side here. So there's two ways that we can find the side MP. Hopefully you guys can see that since this is the hypotenuse side MP, we can use the Pythagoras theorem. The Pythagoras theorem, Pythagoras theo. We can use the Pythagoras theorem, or we can use the trigonometric ratio since we already have this angle here. Since we already have this angle here, we can use the trigonometric ratios. You guys will do it with the trigonometric ratios on your side. I would just do it with the Pythagoras theorem, and then we'll confirm if we find the same answers. Let's do that, guys. So MP MP squared is equal to Pn squared plus Mn squared. So this side square plus this side square is equal to this side square. This is the Pythagoras theorem. You know, you can go and verify it on the previous notes.
Yes.
Yeah. So
The answer
MP,
is
what answer did you get?
18.9 units.
18.9 units. Did you use the trigonometric ratios or the Pythagoras theorem?
Uh, I just what I did, I take cos. I said equal cos. I said cos.
Mm. Yes.
After that, I said adjacent over hypotenuse. Over adjacent
Okay. Yes.
over opposite.
Yes.
And then I take 15 divided by 37.52.
Okay.
The answer will be the same.
Oh yeah. Okay. That's fantastic. That's fantastic. Thank you for doing that. So you can see, you could see the answer must be the same whether we are using the Pythagoras theorem or we are using the trigonometric ratios.
Whoa,
So it's the same
whoa,
thing. It's the
whoa.
same thing. So you basically have your 12 marks now. You have your 12 marks, you know. So if we are clear on this one, oh, we still have to do question 5.2. I want us to do all of these questions today, guys, so that tomorrow or always on Wednesday, we can start with trigonometric functions and then maybe do geometry on Friday or something. But we'll cover everything. We still have like the entire month of August before you start writing and stuff. Okay. For the 5.2, 5.2, let me okay, maybe let me just copy this. Copy for 5.2. Paste. 5.2. Let's go on. 5.2. For 5.2, they are saying calculate theta if 2 sine theta plus 15 is equal to 1.462. So this is what we are given. Sine theta plus 15 degrees is equal to 1.462.
Divided
So
by 2.
we divide by 2, I was about to ask, does any of you have an idea? Yes, we divide by 2. Prime plus 15 is equal to, okay,
0.7 31.
0.731. And then what do we do next?
We say theta plus 15
Theta plus 15. Mm-hmm.
equal 47 degrees. I will 47 degrees.
How did we get the 47 degrees? By saying
Use
sine inverse, right?
sine -1. Yes.
Okay, 0.3. Yes. Don't jump steps, guys. Okay. The answer that we
Yes,
get there is what? It's 47 degrees.
yes.
Okay. It's 47 degrees. And then let's just say theta is equal to 47 degrees minus 15. What
15
take? Yes. And
equal
then
32 degrees.
32 degrees. This is our final answer. That's your 3 marks. That's your three
Wow.
marks. Okay, guys. If we are clear on this, let's move on to the next question.
Ah, 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 ah.
To the next
Yo.
question. Okay, now let me put it this side first. Yes. So okay, it's question 4 again. Question 4. Okay, so given 4 cot theta plus 3 is equal to 0, and then we are told that theta will be between uh 0 degrees and 180 degrees. So if they are saying it's between 0 and 180 degrees, it should click in your mind that it's within which quadrants? These two quadrants. One, two quadrants. So theta will fall between these two quadrants because we have 0 degrees here, 90 degrees, 180 degrees. So they are saying theta is greater than 0, but less than 180 degrees. So any of the angles we find when we solve for theta is gonna be between 180 degrees and 0. Okay, so what are you saying? Use a sketch to determine the value of the following. Um, do not use a calculator. Cos theta. So we are asked to use a sketch to determine the value of the following. So what do we do in such a case, guys? Does any of you have an idea?
I, I cannot see
Okay.
clear, but
Mm, we need to start by rearranging what we are given there first, and then we will work with it to find the value of cost data, you know. So
I think we
let's
have to
work on
use quadrant 2.
quadrant 2. Okay, why quadrant 2? Um, Okay.
Because it's 90 degrees. Wait. Oh,
It's
it's 100.
mm,
It's
180
between
and
180 and 0 degrees.
is is. But what we need first to do is to rearrange this thing here. I wanted you guys to see that we need to rearrange what we
Rearrange the equation.
is 0. Okay, and then um do you guys remember that cast method? I think let's also put it here. Let me use a different color. The cast method. CAST.
Yes.
The cast method, and we say all of these things are sorry, all of the trigonometric ratios are positive in the first quadrant,
So just
and
quite.
then on the second quadrant, which one is positive?
2.
Which one is positive
24.
on the second quadrant?
Sine.
It's sine, yes. And then on the third quadrant, which one is positive?
Tan.
Tan.
It's sine. On the fourth quadrant, which one is positive?
Cos.
Cot.
It's cos. Good. Yes. So when we rearrange this, and then let's say maybe we happen to find um what you call this thing, a negative ratio, we'll automatically know that it doesn't fall here on the first quadrant because all of the trigonometric ratios are what are positive in the first quadrant. So but we're also given this restriction here that it cannot be above 180 degrees. So we'll be left with quadrant two. So one of you answered that we're going to use quadrant two. This is how we get to that. I wanted to show you that, guys. Okay, let's rearrange this. We transpose the 3 on the other side, right? Cot theta is equal to minus 3, and then we divide by 4. Divide by 4 is cot theta is equal to negative.
3 over
Uh,
4.
yes, that's your cot theta. But we said theta is the inverse of what?
Of
Oh,
course.
the reciprocal of cos. Yes, the reciprocal of not cos, not cos. This is
Sine.
Oh,
cot. No, sine is cosec, cos is sec. What's the other one?
tan.
Yes, it's tan. So tan theta is equal to uh minus 4 over 3.
Over 3.
Remember, yes, we are flipping it because it's 1 over cot. It's 1 over tan, sorry. That's how we got this. So when we use tan, it's gonna be 4 over 3 instead of 3 over 4. Okay, so we're gonna have this, and then yeah, you can use the ruler parts. We'll just estimate here, you know 1 2 3, uh say 4, 1 2 3 4. Okay, so we also remove this. So it's tan theta from here, tan theta negative 4 over 3. Okay, so what is the ratio of which side is 4? Is it the opposite or the adjacent side when we are
Adjacent
dealing with
side.
tan? Remember, tan is tall, right? So O is the one that's above. So it's the opposite. O is gonna be the opposite of which is 4, and then adjacent will be 3. Tan is opposite over adjacent. Where are the ratios? Keep this in mind. Uh, Tan is opposite over adjacent. To start with the opposite over adjacent. So if our angle theta is here, somewhere here, uh, sorry, just erased everything. This will be the opposite side. Okay, here. Let me just
Sine.
draw this. Just draw
Oh,
this.
sine. It is sine.
No, it's still tan. We're still dealing with tan. You know.
Oh, so sine is the opposite of tan.
No, tan here is the opposite of cot. We changed cot. You know, but tan
Oh,
tan deals with two sides. Remember that sine deals with what? With opposites and hypotenuse. Let's come back here. Sine deals with what? Opposites and hypotenuse. It's the opposite side and the hypotenuse side. You know, but tan deal with opposites and the
it's over
adjacent.
adjacent.
Yes, and remember on that question we have what? We have negative 4 over 3. Tan theta is equal to negative 4 over 3. That means this 4 stands for what? For the opposite side. And this 3 stands for what? For the
Adjacent.
adjacent side. Yes. Yes. So let's come back here. Let's come back here. So, okay, our adjacent side is 3. It's 1, 2, 3. We're gonna have 3 here, and then we're gonna go up like that. Come back here, and then our data will be here. So, okay, here will be 4 units,
Can I
and
ask
then
a question?
yes, you can.
Why did you write the square on sine side? Why why I think
Oh,
you're going to write the score on tan.
on tan, this triangle. You know why I didn't write it here on tan? It's because this angle they said is
It's
between what?
between 180 and 0 and
Ye-
180.
Yes, the angle is between 180 and 0. So our triangle will be between
On
these two quadrants. And another thing, remember that we have a negative ratio here. And tan what is tan? Tan is positive here. Tan
yes,
is positive here. So we can't write it here because tan is positive here. And we also can't write it where? On the first quadrant because
on the
all
first quadrant
ratios, yes, are
are
positive.
positive.
Yes. So we have to write it here. Here only sign is positive. So the rest tan is negative and cos is also negative, on these quadrants. Only sign, and the ratio that we have here is what? Is negative. So that means our triangle needs to be in this on this quadrant, you know, to fit these parameters so that the ratio it can conform with the ratio, the negative ratio, but also with the angle, with the restriction that we are given there, that it needs to be between 180 and 0 degrees. I don't know if you understand me.
I think we understand.
Okay, so that's what we have right now. Okay, and then so it's 3 and 4. What did they say? Okay, use a sketch to determine the value of the following. Do not use a calculator. So we are given 3 and 4. We need to first calculate this side here. You know, we need to calculate that side there because if we were to use what you call this thing, the angle is gonna confuse. So, I want to actually ask, how are we gonna find that side there, the hypotenuse side? We have these two sides here. This angle is 90 degrees. How are we gonna find that side there, this side?
This is a
Negative
high
3
tech.
over 4 times 4 over 3.
3/4 times 4/3. Uh, Someone said Pythagoras something.
Yeah, Pythagoras theorem, I think.
Yes, yes. So we're gonna use Pythagoras theorem because what do we have here? We have a side and a side, and we don't yet know the
The
value
angle.
of these. Yes. So we just know the sides. So if we have sides, we're gonna use what? Pythagoras theorem. Copy. Let's come this side. Paste. Okay. Let me also copy this. Let's paste it here. Okay.
Pythagoras
So with
theorem.
Pythagoras theorem, we're gonna say that is what is r squared is equal to let's say a squared plus b squared. Okay, this would be our a and this would be our b. R squared, our a is -3, even though it's gonna result in a positive because a negative times a negative, it's a positive. So no need to worry about that. Therefore, r squared is equal to 3 times 3. That's that's 9, right? Plus, oh, 4 squared. 4 times 4 is
64.
16.
Oh,
R squared, 9 plus 16
25.
is 25. And then we put the square root on both sides. Plus the square root of 25 is 5. Yes. So
Oh,
we
uthathe lo
now have
4
the sign.
ungala. Adjacent side. Opposite side
Hmm.
no-3 adjacent side.
Yes.
Wabahlanganisa.
Hmm. This is what's the Pythagoras theorem. Pythagoras theorem. Okay. So let's go ahead. We said we have 5 here, 3, 4, 5. Okay. So okay, cos it's 4.1.8 cos theta. We said theta is which side and which side? Sorry, cos.
Opposite over hypotenuse.
No, cos is soccer, tower, cos is CAH, right?
Oh yeah, adjacent over hypotenuse.
Is A over hypotenuse. Okay. Here's our theta. Which side is next to theta? It's this one. 3.
Side.
That's that's the adjacent side.
Oh yeah.
Cos theta is equal to cos. Okay, the adjacent side. What's the value of the adjacent side? Remember, guys, that we are in the negative side of what? Of the x-axis. So this is actually -3. I should put a sign. So the adjacent side is
Adjacent side,
negative.
I think it's -3
Yes, it's -3, and the hypotenuse side
is 5.
is 5. Yes. Therefore, yes, this is actually the final answer. Because we are not required to calculate the value of theta. Just the value of cos theta is -3 over 5. This is your final answer, and there you have your 4 marks. You have your 4 marks, and then let's move ahead to question B. 4.1.1 B. Let's say 3 sine theta times sec theta over tan theta. Okay, so the easiest way is just to break this thing down, take each ratio, and then we'll
From the
put it back.
calculator. Let me take my calculator.
No, you can't use a calculator. Do not use the calculator. You see here, we do not use a calculator. So we're just gonna say, for you to simplify it for you guys, what is sine theta?
Sine theta. 4/3.
It's 4. No, we can't use 3. Which side are we considering? Come back here,
Hypotenuse. Oh, opposite over hypotenuse.
and
Or 4
then
over 5.
it's 4 over 5. Yes, it's 4 over 5. And sine theta is positive because the 4, it stays, it's above the 0 axis. This is x and
That's
y
right.
axis. Yes. So let's come here. We just break it down. Sec theta is equal to, okay, which sec, do you guys remember which reciprocal that sec stands for? Which reciprocal?
Cos.
It's cos, yes. So it's gonna
Oh, it's
be,
4,
yes,
5 over 4.
So it's gonna be an inverse of 5 over -3.
yes, yes, it's gonna be an inverse of 5 over -3. Okay, it's 5 over -3 because sec theta is equal to 1 over cos theta, equal to 1 over cos theta. So this is how we got this, guys. This is how we got this. 5/3. Is everyone clear on that, or should I explain it more? It's those things of inverses or reciprocals. Don't be shy to ask question to ask if you don't understand, guys. I'm here to help you and to make
I
sure that
don't understand.
okay.
Can you
I
start
will
again? Oh,
on the sec part, right? Okay, so here let me use a different color. Sec, we said sec theta is equal to, let's go back to the reciprocals. Sec theta is there. Well, here is what I'm looking for. Sec theta is equal to 1 over cos theta, right? Sec theta is equal to 1 over cos theta. Okay, that's what we have. That is what it's an identity, if you may say. It's 1 over cos theta, cos theta. So let's rewrite this. Let's take cos and times it with sec cos theta times sec theta is equal to 1. And then let's divide by sec on both sides, sec theta. Okay, therefore cos theta is equal to 1 over sec theta. Okay, cos theta is equal to 1 over sec theta, because we can't just, well, we can, since we know that sec theta is the reciprocal of cos theta, but I want you guys to work with what we are familiar with. Just keep on working with this cos, because we are already familiar with. Okay, let's come here. We said cos theta is equal to what? Cos theta is equal to -3/5, right? Let's put -3/5 here is equal to 1/1 over sec theta. 1 over sec theta. And then you can simply flip, change this thing, put to make sec theta a numerator, just put it on top, and then we also need to change this side. Or we can take the longer road, of which is the cross multiplication. We would say sec theta times 3 and 5 times 1. Okay, -3 sec theta. If I wanted this to fit in this page, -3 times sec theta is equal to 5. Are you guys still following so far? We did the cross multiplication. 5 times 1, sec theta times 3 is equal to 5. Is equal to 5. Are you guys still following?
yes.
And then from here, we simply might,
Divide both sides up with -3.
yes, then we'll end up having sec theta equal to what? -5
5
over 3.
3/3.
Yes, this is how we got that. You know, this is how we got that.
Wow.
Okay, that's how we got that. But guys, please just learn to see these things. Yeah, let me just put some shield so that, yeah, it's not part of the answer that we are doing here. Yes, that is our sec theta. And then we have gotten the ratio for sec theta and for sin theta, these two ratios. And then now we are looking for the one for tan theta. Tan theta. Tan is a what? Which side are we looking for when we deal with tan?
Opposite of adjacent.
Opposite of adjacent. And our opposite here is what? 4 over
Over
-3.
-3.
Yes, 4 over -3. So right now we have everything that we need. We just need to come back and plug it here in this ratio that we were given. Let me copy this into a new page. into AUB.
We want this one. We want this one.
This one.
Yeah.
Yeah, we'll get to that one. Don't worry. We'll answer all of the question parts. What is important is that you guys understand what you are doing. There is no need for me to rush if you guys don't understand. Because I want you guys to go there and get those distinctions.
Yes.
Yeah, just paste this here. Okay. So what we're gonna do right now is simply go in and plug this. So it's 3 times sine we said is 4/5 times sec we said is -5/3 over tan we said is what is -4/3 -4/3, and then you get from there we simply have to divide the negative, sorry, the negative will cancel the negative. Our answer will be positive. That's the first thing. And then here you see that we essentially have 4/3 also. We have 4/3 because if we times this, let's combine that one, you know, let's combine that one so as you see something.
Oh.
3, if we times the numerators here, it's gonna be 4. Ish. Need to write it a little bit lower. Yeah, it's gonna be 4 times 5/5 times 3. You see now we have 4/3 on the numerator and we have 4/3 on the denominator. So basically this 4/3 will cancel this 4/3. Are you still
Wait,
following?
wait, wait, wait. Where did
Okay.
the sign of -3 goes?
The sign. Remember we had a negative on the denominator and a negative on the numerator. So a negative and a negative is a what? It gives us a positive. If we divide a negative and a negative, we're always going to get a positive answer. You can go to your
Oh,
calculator and say -2 over say 3. And you tell me the answer we're supposed to get is a positive 2/3. If we have a negative in the denominator and the negative in the numerator, they're going to cancel. They're going to become positive.
oh yeah. I
Yes.
now
So,
understand.
yes. And then you also understand that's how we're canceling this 4/3 and this 4/3 on the numerator and the denominator.
What?
This 4/3 here, remember that we combine these two terms on the numerator, right?
Yes.
By multiplying them. So we have 4 times 5/5 times 3 over 4/3 on the denominator. So we essentially have 4/3 over 4/3. We can cancel that and then we'll be left with, if we
Five
do
over
that, with 3 into 5/5. This one will cancel. And then 5/5 is what? Is 1, right? And then you
what?
multiply that. 5 divided by 5
Equals 1.
is 1. Then you times that 1. Your answer is supposed to be 3. Or if you don't understand this, you can.
Oh yeah, it's correct because now I see why you say the answer should be 3 because any
Hmm,
number that is times with 1 is equals
hmm,
the one with the, oh wait, because we have 3 on the
yes.
left and we have
Hmm,
5/5 and 5/5 is 1. So 3, so why? Wait, I'm confused. I think there's a step that you miss because I think you should break it down 5/5 and make it 1 and then times it with 3. So that's how it be clear and not be confused.
Oh yeah, let's add that step. So it's 3 times 5 over 5 we said is what? It's
1.
1. So 3 times 1 is what? Is 3. 3 is our final answer. 3 is our final answer. Okay. So and what did they say now? Hence show that um sine what is this? Sine squared theta minus 1 is equal to minus cos squared theta. Okay, let me see if I can do this. Yeah, I'm gonna trade some space there. Copy, paste there. Okay. So now we're asked to show that 4.1.2 sine squared theta minus 1 is equal to negative cos squared theta. Okay, so we already know what sine is and what cos is,
Uh,
right? So we can
is
say cos or sine is what? 4 over, oh, let's say left, we'll start with the left hand side, right? Left hand side we have uh it's left hand side is equal to sine squared theta minus 1. Sine squared theta minus 1 is equal to, here is our sine is 4 over 5, right?
side.
4
It
over
is
5.
left horizontal side. Oh, yeah.
Left hand side, no, it's left hand side, left hand side.
Oh,
Yeah, so this is gonna be 5 over 5 over 4 squared. 4 squared is 16. 4 over, it's 16 over 5 is 25 minus 1. 25 minus 1.
my word.
Okay.
I'm gonna
Okay.
try to calculate it.
Okay, you can calculate it.
If I get negative 0, comma 36.
Negative 0.36. Negative 0.36. So negative 0.36 as a fraction is negative 9 over 25. You can test it as you can say negative 9 divided by 25 and tell me if you don't get negative 0.36.
Yes, I get. I break it down. I press SD.
Oh, yeah, let's just do it as a fraction, you know. So this is the left hand side. Okay, then next we're gonna go to the right hand side. I'll just write it here for the sake of space because, okay, let me just use a different color. So we dealing with right hand side now, which is equal to negative cos squared theta. Where is our cos? We said cos is equal to negative 3 over 5. It's negative 3 over 5. That's our cos. So it's gonna be negative and then in brackets negative 3 over 5. Okay, oh, squared. And then what do we get? 3
Wait,
3 squared. 3 squared is what? Is 9 over 25. Okay, so basically getting the same thing. The same thing, of which shows that these two sides are equal. Therefore, left hand side is
equals
equal
to
to
then
right
right
hand
hand
side.
side.
Yes.
Eh,
Okay.
eh, say, sometimes I get confused. Take time to understand. I don't know why.
To take time to understand that, just keep on practicing and do as many examples as you can, and make sure that you attend these these sessions that we're gonna have, because we're gonna have them until you guys write exams and stuff, and also the questions I give you, attempt to do them, so that when I do them, you can see what maybe I stuck here, and then I will help you through that, and also revise these notes, because I send these notes on the group, you know.
No, I didn't saw them. I'm in a group, but
Yeah, they are in a group, but I'll send them again after we are done with today's session.
I joined late. I saw the group on Facebook, and then I joined, and then I get here right now.
Okay, no, I will send. I will send everything. I will send
All right.
everything. Okay, guys, time is not on our side. Let's at least finish this question. And once again, I will leave these two for you guys to do them as a homework. And then, please, just once you are done doing these two, send them on the group so that I can mark them and see where you are going wrong, or maybe, yeah, just to see how, if you guys understand what we are doing here. Ne?
Wait,
This
let me take a screenshot.
No, don't worry. I'll send the notes. Once we are done with the session, I'll send the notes. You'll see them. You don't have to take a screenshot, but you can take it if you want for this too.
I will take it on the group.
Yeah, I'll send the notes. This would be your homework again.
Can you
Homework.
help me with another thing?
Yes, what is it?
Hey, I have a problem with life science.
Oh, life sciences.
Yes,
Okay, okay, we'll fix this, because me personally, I didn't do right now. I only teach maths, but I can also teach physics, life sciences. While I was in high school, I did EGT. I don't know if you guys know EGT. Instead of life sciences.
I don't know EGT, but can you give me where can I find some tutors that can
Yeah,
help
no,
me?
I will ask with the other guys that the other teachers that we work with here. Yes, and then we'll organize something for life sciences. For life sciences.
All right.
Yes. Or if you have
Please,
question, you can tomorrow writing.
tomorrow we write what?
No, I thought you was gonna say tomorrow you are writing or something. Tomorrow, but tomorrow the session that you guys are gonna have is for physics.
Oh, please, can you tomorrow teach physics term 3 work, please?
Term three work. Okay,
Yes.
just send that on the group. I will have to see who is teaching physics tomorrow. Then I'll tell them to cover term three work. But I think they're already covering it. Expression.
I understand.
Yeah. Okay.
You can
So
continue.
yeah, let me because I want to finish this one before our time is up. I want to finish this one. Copy. So paste. Okay. Once again, Um, we are presented. Also, we are in 4.2 right now. 4.2. Simplify the following expression without using a calculator. It's cos 30 degrees times tan 60 degrees plus cosec squared 45 degrees times sine squared 60 degrees. So we have cosec. Cosec is the reciprocal of which trigonometric ratio? I'm asking a question, guys. Cosec is the reciprocal of which ratio?
Sine.
It's
Sine.
sine. Yes, it's sine theta. Okay. So here I think you can already see that we're gonna use what we introduced earlier, these things here, these ratios. We're gonna use these ratios because they said we must not use a calculator to solve this. We must not use a calculator to solve this. Okay. So we are given cos 80 initially. So yeah, you guys please try to memorize these things, those special triangles that we introduce here, because you'll need to know these things by head, try to memorize these things. I don't know which easiest way you guys will be able to memorize this, but you need to know this, or maybe just memorize these triangles, then you can find the ratio even in the exams, because you can find these ratios for yourself, so that you don't struggle in the exam. But for now, we'll just go with the table because time is not on our side. Cos 30, here's cos 30. The ratio of cos 30 is what? Is root 3 over 2. It's root 3 over 2. Root 3 over 2 times tan 60. Tan 60, here's the ratio of tan 60 is what? It's just root 3. It's root 3 plus cosec squared 45. So we said cosec is the reciprocal of sine theta. So whatever ratio that is there for sine theta, we're just gonna flip it because these two are reciprocals. So let's go to sine 45. Here is sine 45. It's root 2 over 2. So for cosec, it's gonna be what now? It's gonna be 2 over root 2. Are you guys following? 2 over root 2 for cosec squared times sine 60. The ratio for sine 60 is root 3 over 2. Root 3 over 2 squared. So that is that. Okay, now let's simplify again. Root 3 times root 3. You
Come on, I
guys,
have a problem.
are you confused?
Now I get it.
You get it? So with
Yes.
this one, remember we said it's the reciprocal. So whatever ratio that we have for sine, we have to flip it before we put it here. So for cosec, we look for sine 45 here, of which was root 2 over 2. But since we are given cosec here, we need to flip this because cosec is the reciprocal of sine. So it's gonna be 1 over the ratio, of which uh ends up being this 2 over root 2 because it flips.
Sorry, but I can't see the thing that we were watching on where you write these examples.
Uh, you can't see my screen.
Yes.
Okay, I don't know what's happening right now. Someone is okay. I don't know what's happening. Let me share it again. Um, please tell me if you can see it now.
Yes, I can see
Yes, I
it
can
now.
see.
Okay, fantastic. Okay, so yeah, we are here. These are the ratios that we have. So what we're gonna do right now is simply to just multiply. So root 3 times root 3 is gonna be what? If we are times in the square root, guys, we're of the same number. We're always gonna get that number, you know.
Oh, okay.
So it's gonna be 3 over 2. You want me to show you how do we get that?
I think I
Let's
understand.
You understand? Yes, okay,
Yeah.
that's fantastic. So it's gonna be 3 over 2 plus 2 squared is gonna be what? 4. And root 2 squared, this root square roots will cancel the 2. So we're gonna be left with 2 times 3 root squared. The square roots cancels with the exponent 2. We are left with what? With 3 over 2 squared. It's gonna be 4. It's gonna be 4. Okay. Then right now it's just simplifying 3 over 2. 4 times 3, that's 12. 2 times 4, that's 8. So what we have to do now is to find the lowest common denominator. Denominator. Okay. Oh, okay. What we can do, we can start by simplifying this first. Yeah, I think it will make sense.
Or you said 4 times 3.
Yes, it's 12. 2 times 4 is 8. But now I see that we could have easily just say this 4 here cancels the 4 here. You can see that.
Yes.
So we're essentially gonna be left with 3 over 2 on both sides. So it's 3 over 2 plus 3 over 2. And then once we have this, we keep the denominator and add what? And add the
Numerate.
numerators. Yes,
6
so
over
it's 6 over 2. It's equal to 6 over 2, of which is equal to
3 over
4.
3 over 1.
3. Yeah. Okay. So, and then the last one, 4.3. 4.3,
Hey, yo, 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 yo,
4
Jesus.
over 3
Jehovah 36,
sine theta
behold, this is
cos
the one comes here.
37 degrees. Okay, guys,
Yo,
let's
yo,
not
yo,
lose
yo.
focus.
Yo,
Okay,
somebody's coming here now.
guys, who is singing now?
Yeah.
You are disturbing the other learners.
I'm sorry.
Okay, okay. So let's solve for theta. Okay, guys, you lead me through this. What do we do here? We have 4 over 3 sine theta is equal to cos 37. You can see my screen, right?
Yes, I think we find cos 37 first.
Okay, let's find cos 37 first. It's gonna be what? 0.
0.7986.
Let's take at least 4. 7, 9, 8, 6. Yes, and then what do we do? Okay, we have 4 over 3 sine theta on this side. Can we divide with 4 over 3 on both sides?
Yes.
Okay, so divided by 4 over 3 divided by 4 over 3. This one we cancel this one. On this side, we'll be left with sine theta is equal to 0.7 divided by 4 over 3. Uh, we're getting what's
989.
0.5989. Let's take the other one. 8. It's gonna be 8. Let's round off here. And then once we have this, we transpose sine to the other side, right?
Yes.
Theta is sine inverse 0.5988. And what is our theta?
Our theta is 37 degrees
37. Now they say we must correct to 2 decimal places.
or decimal
Hmm.
36.80.
80. Yes, 36.80 degrees. And that is your answer. And that is your answer. This is your homework, guys. You will see it's on the PDF that I will send in the group. Yeah, today's session was really fantastic and thanks for attending. Someone will be teaching you physics tomorrow, and then I will see you on Wednesday. Please do that homework. You can just do it as soon as I send it. I send this PDF right now on the group. Just get into doing this homework, and then yeah, we'll start with it and then introduce trigonometric functions and yes, do examples for that. Yeah, thank you for attending, guys. See you soon.
Bye.
Sure.
Bye. Thank you.
Cheers.
We enjoyed the lesson.
Okay, thank you, guys.
See you on Wednesday. Where is Trigonometry?